Hi friends, this is Dr. R. Jalababu. Welcome back to Graphs in Chemical Kinetics. In last video, I explained about the graphs related to differential rate law equation. In this video, I will explain the graphs related to the integrated rate law of zero order, first order, second order, and third order reactions. The general formula represent integrated rate law for different equations, different orders of the reactions. A naught, that is the power 1 minus n, that equals to A power 1 minus n minus n minus 1 kt. So this is the general integrated rate law. By using this formula, we can write the integrated rate law equation for any order of the reaction except first order. So for zero order reaction, here the n value, n equals to 0. So the n value is substituted in above equation. We get A naught, that is the 1 minus 0, equals to, that is the A power 1 minus 0 minus 0 minus 1 kt. Okay. So here 1 minus 0 1, so that is the A naught. Here 1 minus 0 1, so that is also A, and that is the minus into minus plus, so that is the plus kt. So this is the A naught equals to A plus kt. So A naught is the initial concentration, A is the concentration after time t seconds. Now, so the A comes to this side, then what happened? A naught minus here A, that equals to kt. So this equation in form of y equals to mx. So A naught minus A y. So the k, here k naught, here k naught, and this is the kn. So the t on x-axis. So the graph here on y-axis, A naught minus A. So the initial concentration minus concentration after time t seconds. Now on x-axis, the time t. Now the slope, so there is the no intercept, so the straight line from the origin, so it gives slope, the slope equals to k naught, zero order rate constant. Okay. So from this relation, we can write another form of equation, that is this k naught to t to this side. Now we can write a equals to, that is the a naught minus k naught t. So this plus k naught t go to this side, minus k naught t. So the a equals to a naught minus k naught t. So from this relation, that is the y equals to, that equals to, this is the c minus mx. So the graph, so this is the y-axis concentration of the reactant A after time t seconds. Now on x-axis, that is the time. Now that is the m is the slope. Here minus m, that is the negative slope. So the negative slope relation, so this is the negative slope. So here the slope equals to minus k naught, and the c is the intercept. So this is the c intercept. So this is the intercept c. So this is the, for zero order, the concentration after time t seconds A versus t. So the negative slope minus k naught. So this is the zero order graphs based on the integrated rate law. So this general integrated rate law, that equals to a naught 1 minus n equals to, so that is the a 1 minus n minus n minus 1, that equals to kn t. So for this second order reaction, so the n value, n equals to 2. So the n value substituted in the above general formula. Now a power 1 minus 2 a naught, here a power 1 minus 2 minus, that is the n equals 2 minus 1, that equals to k2t. Here a power 1 minus 2, that is the a power minus 1, 1 by a naught. Here also a power 1 minus 2, that is the minus 1, here 1 by a, and this is the minus 2, that is the minus into minus plus 1, so that is the minus 1 minus k2t. Here minus k2t comes to this side, then 1 by a, that equals to 1 by a naught, so that is the plus k2t. So from this relation, So this is in the form of the y equals to, this is the c plus mx form. Here the graph, so this is the y-axis, this is the x-axis. On y-axis 1 by a, here on x-axis time. Now there is the intercept with positive slope plus m and with intercept. So now the graph with the intercept and positive slope like this. So the slope that equals to m, that equals to k2. Here the intercept, that is the 1 by a naught. So this is the 1 by a naught. This is the graph related to second order 1 by a versus t. So this is the positive slope, that is the intercept, that is the slope gives the k2. Next we derive another relation here. So the k2 t this side and 1 by a naught comes to this side. So these two groups on rearrangement we get that equals to k2t equals to 1 by a minus 1 by a naught. Here that is the t equals to, the k2 come to this side and 1 by k2 and 1 by a minus 1 by a naught. Okay, so this t equals to the k2 on multiplication with 1 by a minus 1 by a naught. Here 1 by k2 into, that equals to 1 by a minus 1 by k2 a naught. Okay, so this equation in form of y equals to m, and this is the x and this is the minus c. So y equals to mx minus c form. So this the t time on y axis and 1 by a on x axis and the 1 by k2 slope, and this is the minus c, this is the negative intercept, that equals to 1 by k2 a naught. Okay, so the graph, so this is the y-axis, y-axis this is the time, and on x-axis that is the 1 by a. So this is the slope 1 by k2 and negative intercept. So that's why the graph like this. So here this is the 0 and the above values, this is the positive values, and this is the below the 0, that is the negative. So this is the intercept C. So the C is the negative. So that equals to minus 1 by K2 A naught. So here the slope equals to 1 by K2. So these two graphs related to the second order integrated rate law equation. For third order reaction, the, the general formula to derive the integrated rate law A naught 1 minus n, that equals to A 1 minus n minus 1, that is the K and T. So for third order reaction, n equals to 3. So now that is the A power 1 minus 3, that equals to A power 1 minus 3 minus 3 minus 1 K3T. So here A power 1 minus 3, A power minus 2, that means 1 by A power 2. This is the A naught. This is the A naught. And here also A power 1 minus 3, A power minus 2, that means 1 by A power 2 minus, and 3 minus 1 2, that is the 2 K3T. Then minus 2K3T comes to this side, and 1 by A power 2 equals to 1 by A naught 2. So that is the minus, so here plus 2K3T. So this relation in form of Y, this is the C, and this is the mx. So the graph, this is the y-axis, this is the x-axis. On y-axis 1 by A power 2, and on x-axis time t, and the slope with intercept. So this is the slope. So the 2 K3, and this is the intercept 1 by A naught power 2. And the another relation here, the 2 K3 T in this side, and 1 by A naught 2 comes to this side. These two groups on rearrange, we get 2 K3T equals to 1 by A power 2 minus 1 by A naught power 2. Here T equals to 1 by 2K3 1 by A power 2 minus 1 by A naught power 2. Here multiplication of these 1 by 2 k3, 1 by 2 k3, so into 1 by a power 2 minus, that is the 1 by 2k3 a naught power 2. So this relation, it is the y equals to, this is the m and this is the x and this is the minus c. So in form of y equals to mx minus c, so the y-axis and this is the x-axis. So on y-axis time t, on x-axis that is the 1 by a power 2. So here that is the negative intercept. So that's why the graph like this, and so this is the 0 and below this is the negative values and this is the negative intercept c. The c equals to 1 by a naught power 2. Here slope equals to 1 by 2k3. So this is the third order graphs based on the integrated rate law equations. So we discussed about zero order, second order and third order except the first order. So for the first order, the general formula is not applicable. For first order reaction, ln a naught by a, that equals to k1t. So this is the logarithmic form of the equation for the first order reaction. So from this relation, so the k1 comes to this side and the t equals to 1 by k1 ln a naught by a. So from this relation, so that equals to y equals to m x form. Another relation, slope equals to 2.303 by k1. Here y-axis that equals to time, on x-axis ln, so that is the a naught by a, and the slope, there is a no intercept, so that is the straight line from origin, and the slope equals to 1 by k1. So the graph related to this first order reaction based on this equation. But this relation in form of the log base 10, now we can write here, that is the t equals to, that is the 2.303 by k1 log base 10 a naught by a. Here ln x equals to 2.303 log base 10x. So based on this formula, the natural logarithmic form of equation is conversion into the logarithmic form of equation log base 10. We get this equation. Now this equation is also similar to y equals to m, and this is the x. So the same graph here on y-axis time, here that is the log base 10 a naught by a. So from this relation we can write ln a naught by a. So here that is the ln a naught minus ln a, because ln a by b equals to ln a minus ln b. So based on this relation, ln a naught minus ln a, that equals to k1t. Now this minus ln a comes to this side and the k1t come to this side. So that is the ln a equals to ln a naught minus k1t. So this relation that equals to y equals to, this is the minus mxc. So y equals to minus mxc. Here the negative slope and with the intercept. So the graph on y-axis, that is the ln a, on x-axis that equals to t. So the minus m, that is the negative slope. So that's why this is the negative slope. So the slope equals to here minus k1, and this is the intercept c, that equals to ln a naught. So this graph ln a versus t gives the negative slope minus k1, intercept ln a naught. So these slopes and intercepts are the important for this graphical representation. And this same relation in form of the log base 10, here how can you write this equation? So that is the 2.303 log base 10 a equals to, that is the 2.303 log base 10 a naught minus k1t. So this equation, so that is the divided with 2.303. So then the 2.303 and 2.303 cancel, and here also that is the in the denominator 2.303. So the finally we get the relation, that is the log a equals to log base 10 a naught, that equals to minus k1 by 2.303 t. So here in the form of y equals to, here it is mx minus c. Y-axis here log a, and here on x-axis that is the t, and the negative slope, here the slope equals to minus k1 by 2.303, and this is the intercept, that is the log a naught. So log a versus t, the slope minus k1 by 2.303. Here ln a versus t, that is the slope is the minus k1. And here also the intercept log a naught. So these graphs related to the first order reaction. So these graphs are the very important in the competitive examinations. So these are the integrated rate law graphs related to the zero order, first order, second order, and third order reaction.